All right, guys, in this rapid review video, we're going to be going over some concepts from Unit 1. Okay, so obviously not all the concepts from Unit 1, but just some quick concepts. So in this one, we're going to be looking at some free response questions from an international released exam. Okay, so and just a couple of things from Unit 1. Okay, so here is a question from the free response exam. I think this is the 2019 one. So it's a IMF and boiling point question. Okay, so basically it's saying the boiling points of ethanol and dimethyl ether are given here. Notice the ethanol has a much higher boiling point than dimethyl ether, even though they're isomers of each other. They have the same exact number and types of elements. So they have the same total electrons, similar in size in terms of how much space they occupy. So their London dispersion forces are going to be the same. So what's the key difference? And obviously it's because we got the OH bond there. So this experiences dipole-dipole interactions, but some very strong dipole-dipole interactions that we call hydrogen bonding. Remember, this isn't the hydrogen bond. It would be the interaction between, the negative dipole of the oxygen to the positive dipole of the hydrogen of another molecule. But we would call that a hydrogen bond, not a dipole-dipole interaction. And then over here, dimethyl ether is going to be polar because of the oxygen there. And so it's going to have dipole-dipole interactions, but because we don't have, remember, that Fon bond, the hydrogen-oxygen covalent bond, we have oxygen-carbon covalent bonds here. We would just call those dipole-dipole interactions. They wouldn't be called hydrogen bonding. Okay, so that's the key difference. Let's see what we said. Okay, so again, I circled that just to remind myself that that's a Fon bond here. I circled that. That's a functional group. It makes the molecule polar, but no Fon bond. Okay. And another thing, just remember, Fon bond is just kind of for us to know. It's not really a technical term, but if you want to abbreviate intermolecular force, you can say IMF, like I did here, and you can say London dispersion forces as well. Okay. So basically, the IMF. So if you read the question, it says, identify the intermolecular force that is most responsible for the difference in the boiling point in terms of this force. Explain why the boiling point is higher. So the force in question is hydrogen bonding. The ethanol is polar molecule and has a OH covalent bond. This results in a stronger dipole-dipole interaction called a hydrogen bond. The stronger IMF compared to the dipole-dipole interactions in dimethyl ether lead to ethanol having a higher boiling point. Okay. They didn't ask us here, but sometimes they ask you to list all of the IMFs. So ethanol would have all three: hydrogen bonding, dipole-dipole, and London dispersion forces, whereas dimethyl ether would just have dipole-dipole interactions and London dispersion forces. Again, they didn't ask that here, but just kind of a review. Okay, so next question. Okay, here they're just asking us to draw the dot structure, and then they're asking us to do the shape. And they have it started, so we know sulfur's in the middle, and we're going to just draw bonds. But remember, the first thing to do is add up the total number of electrons that you're supposed to have in the structure. So each sulfur and each oxygen are coming in with 6 valence electrons, right? They're in group 6A. So you need a total of 24 electrons in your structure. So if we just start off by drawing single bonds to each of the things, and then we add lone pairs, that's going to give us our 24 electrons. But remember, sulfur is one of those elements that needs at least 8 electrons around it, and right now it only has 6. But I can't draw any more dots. I can't just draw a lone pair on here because then I would have 26 dots in my structure, and I can only have 24. So that's when we take one of the unshared pairs on the oxygen and put it into a double bond. Technically, that means the double bond could be here or here, and technically that means resonance. But notice it didn't say anything about resonance structures, and all we had to do was fill in the lines and the dots. And remember, you can have 4 dots here, 2 dots here, 2 dots here instead of just bonds. Okay, and then you can have lines as your lone pairs if you'd like, or you can just have 2 dots like that. All right. So, and let's talk about the shape. The shape, we got 3 bonds or lone pairs on the sulfur. That's trigonal planar. And if they didn't on this question, but if they did, they asked for hybridization of the sulfur. 3 bonds, 0 lone pairs are just 3 total domains. That's sp2 hybridized. All right. So that's rapid review video number 1. Okay. Come back tomorrow for rapid review rapid review video, and of course it froze there. Number 2. All right.